These are your notes for 6.2, which is properties of radicals and rational exponents. You may want to stop and start these notes so that you're able to attempt some of these problems on your own. Looking at this first part, it's just kind of going over what the different powers are called. You may recall some of this from Algebra 1, you may not. Either way, it's all right. It's not any big deal. There's not any big secrets. They are listed right down here if you want to look at those and then try to match these first. You're starting off with a to the negative 2. So you got a negative exponent. So anytime you have a negative exponent, you take the reciprocal. So this is the same as 1 over a squared. ab to the fourth, that is the power of a product. Okay, so you got two things that you're multiplying and then they're raised to an exponent, and that's going to be a to the fourth, b to the fourth. Our next one, a cubed to the fourth, is the power of a power. So that's going to be, you multiply those two exponents and get a to the 12. And the last one, you have a cubed times a to the fourth, and that's going to be a product of powers. You've got two things different powers that you're multiplying together, and in this case you just add those powers, so it's going to give you a to the seventh. Our next one is going to be the power of a quotient. You've got two things that are divided that you're raising to a power, and in this case you can write it as a cubed divided by b cubed. Our next one, you have a quotient of powers. You're dividing two things to powers, and in this case you just subtract those powers, so that gives you a to the fourth. A to the 0 is your 0 exponent, and any number to the 0 power is 1. Now you're just trying these out. So 5 to the 2/3 times 5 to the 4/3, you're going to add those. So 5 to the 2/3 plus 4/3, which is 5 to the 6/3. 6 divided by 3 is 2, and 5 squared is 125. 3 to the 1/5 times 3 to the 4/5 is 3 to the 5/5. Any number divided by itself is 1, so 3 to the first is just 3. 4 to the 2/3, and then I've got a power to power, so I'm going to multiply these. 2/3 times 3 is 2, so 4 squared, which is 16. 10, the 1/2, times 4 is 10 squared, which is 100. Here I'm dividing, so I'm going to just subtract these powers. So 5 over 2 minus 1 over 2 is 4 over 2. 4 divided by 2 is 2, and 8 squared is 64. 7 to the 2/3 minus 5/3 is 7 to the negative 3/3, or 7 to the negative 1. And I know negative exponents mean to take the reciprocal, so that's 1 over 7. You can use these properties with radicals also. So square root of 3 times square root of 12 is the square root of 36, which is just 6. Cube root of 5 times 25 is the cube root of 125, which is 5. Fourth root of 27 times 3. 27 times 3 is 81, and the number that multiplies by itself 4 times to give us 81 is 3. Square root of 98 divided by the square root of 2 is the square root of 49. Square root of 49 is 7. The fourth root of 4 divided by the fourth root of 1024 is going to be the fourth root of 1 over, and 1024, 4 goes into 10 twice, 2 left over, 4 goes into 22 5 times, 2 left over, 4 goes into 24 6. Fourth root of 1 is 1. The fourth root of 256 is 4. Cube root of 625 divided by the cube root of 5 is just going to give you the cube root of 125, which is 5. So right down here, all of your different properties. Now these properties show up on your SAT, they show up on your ACT, they show up on TSI kind of stuff, they show up on your STAR test. So this is something that you want to kind of know what these different things, what the rules are that go with them. It's not something that you have to memorize all the property names, but you do need to know how this works in these. So you want to practice these. It shows you both the definitions with variables and examples with numbers. So go ahead, take a good look at that, study it, know it. On the back, we're going to be looking at the same kind of properties we were on the front, but we're going to look at a little bit more difficult cases. So our top one, we have 2 to the 3/4 times 2 to the 1/2. So again, I'm adding, but this time when I'm adding, I have to have a common denominator. So my common denominator, 3/4 plus 1/2, is going to be 4. So 2 to the 3/4 plus 2/4 is 2 to the 5/4. Now, if it will simplify down to be a single number, we want to do that. But 2 to the 5/4 does not, so we can leave it just like that. 3 divided by 3 to the 1/4 is going to give you 3 to the 3/4, because 1 minus a fourth, or 4 over 4 minus 1 over 4, is 3 over 4. Here I have the same exponent, so I can divide the bases. So 20 divided by 5 is 4 to the 1/2 cubed. Now 4 to the 1/2 is the same as the cubed root of 4, and the cubed root of 4 is 2, and 2 cubed is 8. 5 to the 1/3 times 7 to the 1/4, so 5 times 1/3 times 3 plus 7, times 7, 1/4 times 3. 1/3 times 3 is 1, so that's just 5, 7 to the 3/4. Properties of radicals. So the same properties we were working on the front, just now with radicals. Your product property and your quotient property. Here we get the 4th root of 27 times 3 is 81, and the number that multiplies by itself 4 times to give us 81 is 3. Cube root of 250 divided by 2. 250 divided by 2 is 125, and the cube root of 125 is 5. Cube root of 104. So sometimes these don't come out even, and what you're going to do on those radicals is you're going to use that factoring tree. Now when we worked with square roots, we had to have this come out to be we're looking for pairs, but if this is a cubed root, then we're going to be looking for 3's. So right here I have 3 2's. So that could be written as the cubed root of 8 times the cubed root of 13, and the cubed root of 8 is 2. So 2 cubed root of 13 is my simplified answer. Cubed root of, the 5th root of 3 divided by the 5th root of 4. So you can have the 5th root of 3 divided by the 5th root of 4. But you can't leave radicals in the denominator. Okay, we have to rationalize the denominator. Now, I already have a 5th root of 4, okay, and I know that 4 is 2 times 2. So I already have 2 2's, but I need 3 more. Well, 2 times 2 is 4, times another 2 is 8. So I can multiply this by the 5th root of 8 on top and bottom, and I do that so that I have 5th root of 24 on top and the 5th root of 32 on the bottom. And I know that the 5th root of 32 is 2, so I'm going to have 5th root of 24 divided by 2. Now you cannot simplify numbers that are inside your radicals and numbers on there that are not. So this is the simplified version right here. Sometimes you have radicals that are like this, where you've got a rational number minus or plus a radical. What you have to do there is multiply by the conjugate, so 6 plus root 2. So on the top, 3 times 6 is 18, 3 times root 2 is 3 root 2. On the bottom, 6 times 6 is 36, 6 times root 2 is 6 root 2. Negative root 2 times 6 is a negative 6 root 2. Those will cancel. Negative root 2 times root 2 is a negative square root of 4, which is 2. So I'm going to have on the top 18 plus 3 root 2 divided by 36 minus 2 is 34. 7, 5th root of 12 minus the 5th root of 12. So 7 minus 1 is 6, 5th root of 12. 4 9 to the 2/3 plus 8 9 to the 2/3 is going to give you 12 9 to the 2/3. But we got to be careful with this 9 to the 2/3. So I know that if I change that to a radical, 9 squared is 81, and the root here is third. So the cubed root of 81. And 81 is 3 and 27. 27 is 3 and 9. 9 is 3 and 3. So I've got a 3 and the cubed root of 3. So 12 times 3 cubed root of 3 is 36 cubed root of 3. And it's very common to get right here and think that you've got it. Your computer spits back out that it's wrong. Look at it again. Look at what your powers are. You're on the right track a lot of times, you just haven't gone far enough. Cubed root of 5 plus the cubed root of 40. Well, if this were times, we'd be in business, we'd just multiply them, but it's a plus. So we have to look at 40 a little closer. I know that 40 is 8 and 5. 8 is 4 and 2, 4 is 2 and 2. So that could be written as 2 times the cubed root of 5. So I've got a cubed root of 5 plus 2 cubed root of 5. So that is 3 cubed root of 5. 13, cubed root of 27 is 3. And then what I'm doing right here is I'm dividing my power by my root. So 9 divided by 3 is 3. So 3 q to the third. So again, x, 10 divided by 5 is 2. 5 divided by 5 is just a y. Whenever I'm dividing, I'm going to divide their coefficients. So 6 divided by 3 is 2. And then I'm subtracting the exponents. So I have an x, which is x to the first, divided by x to the 1/2. So that's going to be x to the 1/2. 3/4 minus 1/2, or 3/4 minus 2/4 is 1/4. So that's y to the 1/4. Number 16, okay, so we know the square root of 9 is 3. Now w to the 5th means that there are 5 w's underneath that square root symbol. And it's a square root, so I know I need to have 2 of something to be able to come out. So I have 2 sets of 2 w's. So I'm going to have w times w, which is w squared, and I still leaving a w inside the square root. And then I have a minus, have a w on the outside, and I have the square root of w cubed. So that's 3 w's in there. I can bring out a w, multiply it by this w, and get w squared root w. 3w squared root w minus 1w squared root w is 2w squared root w. Sorry about not getting your notes online early yesterday. I'd intended to, and then that just didn't happen. I'm going to go ahead and post these and open up your assignment for 6.2. These will both be due on Friday. Remember that you have a 6 weeks test coming up on Tuesday. If you've got questions, please feel free to email me. And I will get back to you as soon as possible. Or you can also send me a message on Remind or Google Classroom.